Hello, welcome back to another episode of Barely Working. Recently, I've noticed that as artificial intelligence is becoming more and more mainstream, that there is a lot of confusion on certain AI-related topics. One such topic that I've noticed that has been giving people a lot of trouble is deep learning, or machine learning, based on neural networks. As this is the case, in this video, I would like to help break down deep learning and neural networks so that they could easily be understood on a very basic level. Essentially, neural networks can be thought of as networks composed of individual units referred to as neurons. When given some input vector, these neurons will produce an output. They do this using learnt sets of weights and biases. In the simplest type of neuron, a feed-forward neuron, the output calculated will be a weighted summation of each input feature and the bias term passed through a nonlinear activation function. Activation functions are very important in neural networks as they allow neural networks to learn nonlinear functions. Put simply, neurons are composed of weights and biases, which are numbers used to do inference and to compute an output from an input vector. As referenced previously, neurons are units that can be combined to form larger networks. They can be stacked on top of each other or placed parallel to form multiple layers of parallel neurons. Typically, modern neural networks are composed of many hidden layers. That is, layers between the input layer and the final output layer of a neural network. In modern neural networks, it is kind of rare to use feed-forward units as the mainstay of a network. Instead, more advanced neurons are often used when processing sequences of input vectors. These neurons often have more advanced components and connections. Today, many different types of neural units exist, such as recurrent neural networks, which consider decisions made at previous time steps when operating over an input sequence, self-attention transformers, which compare an input vector at the current focus of attention to all other input vectors, and convolutional neural networks, which, as the name implies, utilize a convolution operation. Of these different types of neural units, self-attention transformers are most commonly used in modern text processing applications, while convolutional neural networks have their place in the processing of visual data. Now that we've briefly explained what neural networks are and have taken a look at how neurons work, I would like to now explain how to train neural networks. To train a neural network, we simply shift the weights of the network during training in accordance to some loss function. A loss function is something that we try to minimize during training to achieve good results on some task. If we're trying to classify some text or predict the probability of some word occurring next in a sequence, we could try minimizing cross-entropy loss to maximize the probability of making the correct decision. In a supervised setting, we typically train our neural networks on large amounts of data, shifting the weights to model some data, attempting to minimize loss and errors compared to gold standard labels. This process can take a long time as it can be very computationally expensive. However, once training is complete, we'll have learned weights and biases for all layers of our neural network that can be used to make predictions given some input. If we want to make a prediction using this neural network, do classification, or generate some output, we simply pass in an input to our neural network and use our weights and biases to calculate an output. If you would like to see some cool applications of neural networks, please subscribe to my YouTube channel as we do interesting content with neural networks almost nearly every week. In any regard, if you found this video helpful, please press the like button. If you didn't find this video helpful at all, please still hit the like button. Because, why not? See you all in the next video.